The problem starts out by defining a function that iterates through a number and finds the sum of the digits. So it's going to be called sum of digits, and it's going to have the parameter n, which is basically going to be the number that the user inputs. So the beginning of the function starts out by setting sum to 0, and then it's going to go through a for loop, which basically iterates through each digit in the number and adds it to the total sum. So then to do that, it's going to turn the number, or n in this case, to a string so that it can iterate through. And then it's going to turn that number back to an integer so that it can be added to the total sum. And then in the end, it's just going to return the sum of the digits. Next, I defined a function called prod of digits, short for product. And then it's the same thing, it defines a function that iterates through a number and finds the product of the digits. So for this one's a little different. It starts off by setting prod to 1, and then it goes through a while loop. So while n is not equal to 0, we'll see how that works later. It goes through this part. So this first line is the product multiplied with n mod 10, and then in this case n mod 10 pretty much finds the last digit of the number. So like if the number is 966, n mod 10 would be 6. So then it's going to multiply that with the product so far. So far the product is 1. Let's say we take 966 for example. The product is going to be 1 times 6, which is the last digit. So then right now the product is 6. And then the next part is float division. So then n divided by float divided by 10 is going to return the number without the last digit. So then if we take 966 again, it's going to return 96. So then the new n, so the new number, is going to be 96. So then since n is not equal to 0, we're going to continue it again. If we're taking 966 as an example. So then right now we're at n is equal to 96. So then if we mod 10, we're going to get 6 again as the last digit. So we're going to multiply that with prod, which is at this moment 6. So 6 times 6 is 36. So right now prod is going to be equal to 36. And then n, so we're going to do 96 float divided by 10. So it's going to get the digit chopped off with, that number chopped off with the last digit. So then it's just going to be 9 instead of 96. It's just going to be 9. So the new n is 9. And then since it's not equal to 0, we're going to do that all again. So right now prod is 36. So then we're going to do 9 mod 10 is just going to get 9. So then 36 times 9 is, let me do the math real quick. 36 times 9 is 324. So then prod is going to be 324. And then n is going to be 9 float divided by 10, which is going to equal to 0. So then since it's equal to 0, we're going to exit out of the while loop, and then it's going to return prod, which is 324. So then that's just, with 966 as an example, the product of all the digits is going to be 324. So that's just how the function works. It returns the product of the digits. So then moving on, we have another function. It defines I defined a function that returns the additive persistence and the additive root. So then just in terms of this function, the additive persistence is going to be cycles and the additive root is just going to be n. It uses the parameter n, which is just going to be the number that user inputs. It starts off with cycles equals 0 because just starting off there's just no cycle yet. Like there's no rotations of like the function. This part finds the length of the number. So then first I had to convert the number to string so that it can find the length. And then while the number still has more than one digit, we're going to go through the loop. So then this pretty much finds the sum of the digits using the above function right here. So then that sets it to n. So that n is the sum of the digits. And then we're going to add 1 to the cycle since the summation is performed. So each time the summation is performed, 1 will be added to the cycle. So then that's going to equal the additive persistence up here. And then afterwards it's going to find the new length of the number, so then it's going to set length number to the new length of this the length of the new number. And then it's just going to return the additive persistence and the additive root, so it's just cycles and n. Then I have another function. I defined another function that returns the multiplicative persistence and the multiplicative root. So it's pretty much the same thing, except this time I'm finding the product of the digits instead of the sum of the digits. And then it's going to do everything pretty much similar. It's going to return the cycle and then n, which is the persistence, and then the root. So this function is the exact same as this one, except it finds the product of the digits instead of the sum. So after defining all the functions, the program pretty much starts. So I set run equals to 0. This is kind of for the exit loop. So then while it's 0, then that means the program will continue to run, and if it is 1, then the program exits. So then while run is equal to 0, so that means as long as run is 0, the program continues. This part pretty much prompts the user to input an integer, so whatever number they put here, it's going to convert it to an integer. And then print here is just for a new line, just to format it more cleaner, so it's like easier to look at. Then if the number is a negative integer, then it's going to set run equal to 1, so that means when the while loop runs again, it's going to be equal to 1, so that means the program exits. So then if that is the case, then it's just going to print thanks for playing with numbers, goodbye. If the length of the number is 1, so that means it's just one digit, then it's going to print the additive persistence as 0, additive root as the number, same with multiplicative persistence. And then right here is another new line. And then this else statement is if the length of the number is greater than 1. It's going to print for the integer, then just the number, just to show the user what number they put, or like what number they're finding the properties for. Then cycles and n is just going to get the additive properties using this function up here. And then it's just going to print whatever was returned from the function. So it says additive persistence, then cycles, which is going to be the number of cycles that this function went through. And then this right here is just so that it's on the same, so that the end right here is just so that this print function is going to be on the same line. Same thing for additive root, it's just going to get n from get add properties, so it's just going to be the root. And then it's going to do the same thing for the multiplicative properties. This time it's just going to use this function instead of the add one. And then in there it's just going to print a new line. So to run some test cases, we can start with 1, 2, 3, 4. So 1, 2, 3, 4, it says for the integer 1, 2, 3, 4, it says the additive persistence is 2, the additive root is 1, multiplicative persistence is 2, and multiplicative root is 8. And then it's going to ask, since it's not a negative number, it's going to ask the user to print or to input another number. We can do 999. It's going to do the same thing. We can also do 9876. It's going to print out the properties. Now let's try just one-digit numbers, so we can do like 5. It's going to say additive persistence and multiplicative persistence is 0, and just the number, because that's one digit, so the root is just the number itself. And then if we do 1, same thing, we can do 0, everything's going to be 0. Then if we do negative numbers, so just -1, it's going to exit the program and it's going to say thanks for playing with numbers.